Hello, and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends at Linode. With 200 gigabit private networking, scalable shared block storage, speedy SSDs, and a 40 gigabit public network, you get everything you need to run a fast, reliable, and bulletproof data platform. And if you need global distribution, they've got that covered too with worldwide data centers, including new ones in Toronto and one opening in Mumbai at the end of the year. And for your machine learning workloads, they just announced dedicated CPU instances, where you get to take advantage of their blazing fast compute units. Go to dataengineeringpodcast.com/Linode, that's Linode, today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. And you listen to this show to learn and stay up to date with what's happening in databases, streaming platforms, big data, and everything else you need to know about modern data management. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as O'Reilly Media, Dataversity, and the Open Data Science Conference, and coming up this fall are the combined events of Graphorum and the Data Architecture Summit in Chicago. The agendas have been announced, and super early bird registration is available until July 26th for up to $300 off. Or you can get the early bird pricing until August 30th for $200 off your ticket. Use the code BNLLC to get an additional 10% off any pass when you register, and go to dataengineeringpodcast.com/conferences to learn more and to take advantage of our partner discounts when you register for this and other events. And you can go to dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, read the show notes, and get in touch. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers. Your host is Tobias Macy, and today I'm interviewing Jeremiah Lowin about Prefect, a workflow platform for data engineering and data science. So, Jeremiah, can you start by introducing yourself?
Yeah, first, Tobias, thanks so much for having me on your podcast. I'm the founder of Prefect, as you mentioned. Prefect is a data engineering startup that's based here in DC, and we make some amazing software for building and executing data workflows.
And do you remember how you first got involved in the area of data management?
Yeah, my career has been a very slow but steady progression from the data science world into the data engineering world. I started out as a statistician. I was doing a lot of analytics and some machine learning work in the very early days there. But over the course of my career, I kept moving more and more into the engineering space simply as a matter of necessity. In order to get these analytics that I was being, that I had been hired, that I was being paid to produce into the world, and in order to make them useful, I had to keep taking steps towards how do we productionize them? How do we deploy them? I had to understand my infrastructure. And this was a product of a few things. First, the amazing software and developer tooling that's become available over the last decade, which just made it possible for an increasingly small team to handle this type of work. But also, hand in hand with that, the fact that I kept moving on to smaller and smaller teams, even as I moved into larger and larger institutions. In a recent role, I was sort of a team of one, handling all aspects of a massive analytics effort. And if I wasn't able to handle both sides of that equation, the data science side and the data engineering side, I was sort of lost. And that was when I first became involved in the Airflow project. That was literally a lifeline to me to take the hours in the day that I had and the amount of work that I had to do, which did not fit in those hours, and start automating it.
And so, before we get too far into it, can we just start by describing a bit about what Prefect is and your motivation for creating it and some of the story behind building the project in the company?
Absolutely. So in a simple sense, Prefect is this tool that I always dreamed of having. In as much as my career has been a progression from strictly data science into this hybrid of data science and engineering and data engineering, it's been a quest for how do I build tools faster? And how do I deploy ideas that I didn't even have yesterday into production tomorrow? So as I mentioned, I became involved in Airflow when I just needed to automate things. I needed to kick things off. But as I stabilized my infrastructure and I started turning my attention back towards the sort of more fun, ephemeral, dynamic data science work that I was doing, I very quickly ran up against the limitations of Airflow as a tool. I was doing things that were fast, programmatic, parameterized, dynamic, scaled, different, and Airflow just doesn't quite have the vocabulary there. So Prefect started life as an experiment to see if we could marry some of the things I really loved about Airflow, which is, the idea that it has state and state dependencies, and you can do things like run a task if something else failed, with everything that was so amazing about living in the data science world, right? These beautiful analytic tool sets and pipelines, and Dask in particular is one that I was making heavy use of. And so the very, very, very first prototype of Prefect was, can I take Dask's pipelining technology and combine it with a semantic similar to Airflow's successor failed? And in doing so, can I get the best of data engineering tooling and the best of data science tooling in one project? And that prototype was so impactful in my work, even as a nothing, as a prototype, that very quickly we started turning our resources and our attention into developing it alongside Airflow, and fairly soon it subsumed the work that we had previously given to Airflow.
And so one of the things that you mentioned in there is the fact that you were looking for some of the dynamicism and iterative capabilities of your data science workflow within the data engineering context. And so I'm wondering if you can just characterize the assumptions that were baked into tools such as Airflow about what's necessary for being able to do data engineering work, and how that contrasts with the needs of a data scientist, and why it's necessary and useful to be able to encapsulate both of those styles of workflow into one tool or platform.
It's a very good question, and I'll give you the best answer I have. I think that broadly, if you look at the data science world and the data engineering world and how they've evolved in the last 5 or 10 years, you see a philosophical difference that's sort of revealed in the choices that software makes in either camp. In the data engineering world, we tend to have state-driven software. So you do a thing, and then depending on whether or not the thing succeeded, you will move down one of two paths to a second thing, and then on and on and on. And of course, that takes on a very familiar DAG shape. In the data science world, while we're still dealing with DAGs, the dependency nature is very different. There's this implicit idea that things will succeed. If at any point in a data science pipeline something fails, that's almost always equivalent to the entire pipeline failing. And that's true in pretty much any, if you use any machine learning framework, anything like Dask, Beam, when a node fails, the workflow fails, if you will. And that's because one depends on passing data around, that's the data science world, and one depends on passing state around, that's the data engineering world. And while that's a somewhat a vast generalization of the two, since we started sort of beating this drum about 2 years ago, we see this sort of borne out in almost every set of tools we look at. So the idea of bridging that gap really involves combining a state-based workflow, which is to say you can react to whether something succeeded or failed, with a data-based workflow, which is to say you can react to whether data has been produced by an upstream task, and you can make use of that information however you choose. So this idea of bifurcation of philosophy that then is sort of entrenched by software choices is one that we at Prefect reject. And if we borrow the two best practices that we see in those two fields and literally combine them in these, we have these very rich state objects that drive our system, we can all of a sudden enable amazing things. So we can borrow the power of, for example, the Dask cluster that underlies our system to pump massive amounts of data through the system like any traditional pipeline in a data science context. On the other hand, we can, with no extra work, treat any one of those potentially millions of tasks as a fully independent, not necessarily idempotent, retriable piece of logic from a more traditional data engineering standpoint. And so that idea, more than anything else, that combination of these two practices is what drove us forward. Because the truth is, when you look around, things rarely are one or the other. Or to the extent, let me rephrase that. To the extent that people think that things are one or the other, they're ignoring the fact that at some point those two worlds need to collide. Right? So I can build a model in TensorFlow. I can use a strictly data science oriented approach. But at some point, I need to get that in the hands of someone who can work with it, productionize it, deploy it, make it robust to who knows what. Conversely, if I'm in a data engineering context, I am very rarely going to be completely divorced from the idea of moving data or information, even a parameter, through a system. And so while we can live most of the time in one of the two worlds, there's always this friction, this crossover. And I think I felt it very keenly in my career, just being someone who literally had a foot in both worlds. And so I became very motivated to solve it. Now, what we've learned is that while this friction, this surface area may be relatively small, the time it takes to deal with it is sort of incredible. It is the number one thing that we hear people complaining about. And there's no person in most organizations who's naturally incentivized to solve this problem. Right? The problem that I just described only exists between two teams. Both teams are probably quite happy, in fact. And so by focusing on that, we found a very interesting problem that doesn't have a natural owner, that isn't naturally incentivized to be solved. And so we come along with Prefect, and we found that we can actually solve it in a very general way. And that's been a very exciting, thing to see resonate with our users.
Broadening the conversation a little bit, Prefect is a workflow engine, Airflow is a workflow engine, and you might hear some of these be referred to with other terms as far as like ETL tools or data integration platforms. But broadly speaking, in terms of workflow engines and the capabilities and requirements thereof, there are a pretty wide number of them, but I'm wondering what you see as being the main axes along which the different tools or platforms can differentiate themselves. And among those potential axes, which ones you're focusing on for Prefect that would make somebody choose it over some other option?
By and large, the workflow systems that have emerged today, in the popular mindset at least, are these monolithic and generally unpleasant pieces of software. They require an enormous amount of setup, infrastructure. They are quite opinionated about what you can and cannot do. In other words, they have a very restricted vocabulary. And the things that their creators chose to make first class important really dictate what you're able to do with them. And so, say 5 years ago, when the main activity that you wanted to schedule was hitting a third-party system, waiting for it to complete, moving on to the next thing, that limited vocabulary was fine. All you really need to do is schedule something, execute a script and wait for it to complete. That was a vocabulary sufficient for 90% of work. But that's not really what the modern data stack looks like. The modern data stack I mentioned before is dynamic, and it's fast, it's experimental, it's often broken. And what we need to do is we need to be able to respond quickly, move quickly, and we need to not be beholden to the limitations of the workflow system. I'll tell you a funny story. I met a VC when we were in the early days of seeking to fund Prefect. And he explained to me how he thought a system like Prefect would be deployed into a large technology company that you would recognize. And he described to me this vision of the data process there that honestly was just completely foreign to me. And he had these data scientists in his head who basically received a nice packet of data, and they applied this known model to it, and they produced a report, and then they repeated that forever. And I remember thinking when he was describing this, what an incredible luxury that would be as a data scientist to live in that world where there was almost no challenge. It was like being the veal of data science in a sense. And this image of this data science veal that has stuck with me since that conversation, because that's just not how that's not what using data today looks like. Using data today is this frantic struggle to figure out like what is usable in this data set, what can I extract from it, and where can I put it? And you are lucky when you get that into a repeatable process. So what we need as a result is we need a way to make sure that the workflow system is really governing the workflow itself, the semantics of the workflow, and not restricting the actions that I'm allowed to take, because it would be a mistake if the workflow system pretended to anticipate the needs that I have as a user and my use case. And this is, we spoke earlier about a PyData talk that I gave, and this was the topic of that talk, is the way that people essentially end up having to hack around the assumptions of their workflow system in order to get it to comply to their use case. So what we focused on very much with Prefect, to answer your question directly, is not forcing users to learn a new vocabulary, a new set of actions, but rather just embracing Python as an API. And our design goal is that Prefect should be almost invisible. And Prefect's job is to sit between the actions you want to take. So when you ask somebody to draw a workflow, what they usually do is they draw boxes and then they draw arrows between them. Most workflow systems, as I've described them, restrict what you're allowed to put in the box because they're only capable of handling a relatively well-defined set of actions. but they pride themselves on those arrows, right? We're going to make sure that you go from box A to box B to box C in the right order at the right time. So Prefect takes a very different point of view. We say you can put anything you want in that box. Any valid Python function can go in that box. We're only focused on the arrows. And we will make sure that the syntax, the API that you use to express that workflow, hews as closely to the Python that you are comfortable with as possible. And by eliminating that restriction, that's where we open up into this data science world all of a sudden, and we try to tear down that barrier between the two. We don't need to just kick off a third-party script, or have a very carefully constructed and idempotent task. We will do whatever our users want. If it fits in a Python function, Prefect will happily handle it. And what Prefect brings to the table, again, are those workflow semantics, the ideas of retries, error handling, logging, deploy, et cetera, et cetera, et cetera. So that's really where we're focused, is we want to make sure that no matter what someone brings to us, the answer is yes. Prefect handles this because Prefect literally is agnostic to what goes in that box.
In your presentation that we mentioned, and in some of the blog posts that I read in preparation for this conversation, you introduced this concept of positive versus negative engineering. And so I'm wondering if you can give a bit of an outline about what your thoughts are on that topic and what you mean by those terms, and some of the ways that Prefect itself handles the negative cases for you so that the engineer who's building a workflow doesn't necessarily have to guard against them as religiously as they might otherwise.
Absolutely. So the boxes and arrows that I mentioned ago, it very quickly conversations get silly when you just keep talking about boxes and arrows. So we decided to name them. We call them positive and negative engineering. Positive engineering is what you are hired to do as an engineer, right? This is writing code to achieve an outcome. You want to load a database. You want to run a model. You want to produce a report. Whatever it is that you are trying to achieve, we just call that positive engineering. And then negative engineering, in contrast, is all of the things that you need to worry about to actually make sure that positive code runs. So that's how are you going to package it? Where will you run it? How will you deploy it? What happens if it fails? How are you going to retry it? How are you going to make sure that the data it needs to retry is available? This sort of infinitely complex risk management surface that is orthogonal to the purpose of your code, right? You may have error handling in your code that's related to things you expect to happen and that fit in this positive engineering context. But once your code is out of your hands, or maybe even if it is in your hands, this negative engineering concept just rears its head. And it's hard enough with one task. Everything that I just mentioned could be applied to a single task. When we start to think about how that task interacts with other tasks, maybe it's one, maybe it's 100, maybe it's a completely different workflow, the complexity, the surface area for error just explodes magnificently. And so Prefect, if we quickly reference those boxes and arrows again, if the boxes are positive and the arrows are negative engineering, Prefect is a tool for negative engineering, specifically for eliminating negative engineering. That is the mission of our company. We would like to say to people, you work on the thing that you are hired to do, the thing that you are good at, the thing that you are an expert in. That's the positive engineering. Build that, decorate it with our code so that Prefect's negative engineering goes to work. And all of a sudden, all the things that I just referenced are brought to bear in sort of a best practices kind of way. When we give our code to someone, we are not telling them what they need to write, how they need to write it, what it needs to do, what data it needs to produce. That's completely up to them. Our promise is that if this thing needs to retry, you're not going to write retry code. You're just going to tell us, retry this 3 times and move on. If this thing needs to run as a cleanup only if something fails, you're not going to code that. We're going to know how to do that. We're going to make sure that happens, and we're going to make that guarantee.
And as far as the execution context that Prefect provides and some of the built-in capabilities, I'm wondering if you can dig in a bit more as to how it's actually implemented. I know that you mentioned that it relies heavily on Dask for being able to distribute execution, and that it's using Python as the implementation language. So I'm wondering if you can just talk through some of the design choices and technology choices that you made and some of the overall architecture of the system that you've settled on.
So this guiding principle we have that Python is the API is a forcing function to make sure that we don't rely too heavily on any one technology and that we really embrace a very generalist attitude. So Dask is a a big part of our system. It's how we recommend people deploy Prefect. But if you go into our open source and look at the Dask hook, I think it's less than 50 lines of code because Prefect is a fully customizable modular system. And it's funny, one of our goals was to make this thing that sort of was batteries included, out of the box, super easy to use, encapsulates best practices, but also has this incredibly rich, customizable backend that people can plug whatever they want to, whatever execution engine they want to, into it. And so what we ended up doing to achieve that is we split the project into a series of modules, and each module exposes classes with a very simple API. So just for example, the execution module, if you want to plug this into any backend, whether it's Dask or anything else, there's only two functions that you need to implement on a class. And Prefect will happily interface with any class that implements that API. So taking this from Dask to, you name it, whatever you want, a local process, an asynchronous process, Lambda, whatever you want, it's trivial because you only have to add these. This contract is very simple. And we've taken that throughout the system. So whether it's the environment, so how do we package and deploy a workflow? Does it get put in a container? Does it get written to a file? Does it get sent to GitHub? Again, we spend a lot of time on what is the API? How do we abstract away the bare minimum that's needed to richly express this idea? And then we built a module for that. And so Prefect as an engine is a collection of those modules surrounding, and it's literally called the engine in our open source code, surrounding a very rigorous set of steps that we believe encode the best practices of how we should implement workflow semantics and workflow logic. So there's sort of two pieces to this puzzle that I'm describing. One is that execution pipeline, which is everything I'm describing is open source and anyone can go check it out. That execution pipeline is very clear, well-tested, atomic. It's great code. It's much easier to read than any other workflow engine that we've looked at and compared it to. But on the other hand, it is all driven by hooks that are extensible into these modules we built so that people can rip out any part of our system and replace it without worrying that they lost any of the functionality that workflow logic guarantees. So I already mentioned the execution pattern, the packaging pattern, logging falls under that category. How you want your results handled falls under that category. Really, every piece of it was designed to be modular.
And in the process of building this platform, I know that you have drawn fairly heavily on your experience working on Airflow and with Airflow, both for positive and negative ideas of what to do and what to avoid. I'm wondering, what are some of the other systems or platforms or experiences that you're drawing from for inspiration?
So yeah, no secret that Airflow is a big source of inspiration. I've worked on Airflow for many years, since the day it was open source, as a matter of fact. And more than Airflow itself as a tool, to be honest, was the interaction with Airflow users. So over the course of the last, 4 years, I have worked with hundreds, I don't think it would be an exaggeration to say thousands, maybe it would be, of data engineers who are working in or around the Airflow ecosystem. And so I have cataloged these use cases that are just extraordinary. And that education has been the single most valuable thing, much more than looking at any piece of software, because software tends to be written to solve a problem. And in collecting these hundreds or thousands of problems, we had a very unique opportunity to look around and say, well, what is the problem we should solve here? In other words, I know what my problem is, but maybe my problem is just one outlier in this massive distribution of data engineering problems. And so we had this incredible data set, which informed almost everything about Prefect. And the big challenge that we had was to take these hundreds and thousands of use cases and abstract from that the actual features or the things that we needed to deliver to try and solve ideally every single one. And the amazing thing is when we boiled it down, there weren't that many things. We'd see the same things repeated over and over and over. We'd see obviously speed and scale, number 1 and 2, probably for anyone who's using Airflow. But beyond that, we would see requests for parameterization. We would see a lot of requests for dynamicism, which we implemented as a mapping operator. As there's only a small number of things that would actually solve or really move the needle for the vast majority of use cases that just aren't met by current technologies. But the problem is some of them don't. Some of them aren't obvious, perhaps, when you set out with one specific problem that you're trying to solve, and others of them feel like they're byproducts of a different process. So, for example, passing data around, data flow, is sort of taken for granted by everyone in the data science world. That is how every single tool works. It would be very weird to try and use a tool for data science that couldn't move data around. But on the other hand, as we start to blur the line between data science and data engineering, that requirement is now making it impossible to deploy, in some cases, a data engineering tool that can't even do this most basic thing. And if you go way back into the Airflow history, you'll find one of the first things I added to it is a thing called an XCOM, which was my attempt to solve this problem. Now, with many years more of experience than that implementation, I would never in a million years have done it the way I did it then. I'm a little bit embarrassed by it in some regard, but it is out there. It's too late to change it. But it's a good example of if you just try to tackle one problem at a time and solve it or do it by committee, you're not going to end up in an optimal place. You're just going to solve the problem you thought you had. And so by leveraging not what we learned so much from other tools, but by leveraging this wealth of feedback and friendly relationships that we've built, we ended up in a really amazing place.
And the idea of being able to pass the data itself between the tasks rather than just the current state and a pointer to where that data might reside is definitely something that you said is very valuable in the data science context, and something that I can see would definitely be very useful just in general, because it reduces some potential failure cases where you have maybe issues between permissions across different workers, where the worker producing the data maybe pushes it to an S3 bucket, but then the credentials for the reading worker doesn't have access to it. Just various challenges that can come up along those lines. I'm wondering, particularly when running in a distributed context, whether on Dask or otherwise, how you handle actually being able to pass that data between processes, particularly when you might be dealing with large volumes of information.
Yeah, it's a wonderful question. This is one of those things where it's very easy for me a couple of years ago to kind of pound the table and say, and it has to pass data around, and then to sit and wonder, well, how? How are we going to solve this problem? And the prototype that I always use is not even necessarily across boundaries where we might have two processes running, but they need to literally pass the data to each other. The harder version of this problem is what happens when a task fails and needs to retry in an hour. So it's the same task, but it needs access to the data produced by upstream tasks that themselves are no longer running, right? They're successful, they're done. And so there are variants of this problem when you actually start to map it out that like bring even more complexity and more difficulty to it. So the way that we solve this is by introducing a very originally named class into our open source engine called a result handler, which allows users to specify, well, what do you want done with the result of a task? A good, as you mentioned, a good way to do it is write it into S3, write it into cloud storage, put a network share. Again, this is a class that exposes a very, very simple, I think it's a 2-function API. So anything that you write that's compatible with that API can be used as a result handler. And that tells us, okay, this task produced something. Now we know A, where we put it, and B, how to retrieve it. But what we can't do is we can't just store every single piece of data that's produced by the system. It's not feasible, it's not realistic, it's just untenable. So instead, we started to look for how do we actually know when data is needed? Like, how can we detect and hint to our system that data needs to be passed around? And an easy way to do that is if a task ever ends in any state that doesn't indicate that it's finished, that's a pretty good clue that it's going to need to recreate its data. And so what we do is it's actually not the upstream task that stores its data. It's the downstream task that decides it's going to cache the data it received. And so we turn this problem on its head. And now if that task fails, or if that task needs to get data somewhere, or rather I should say that task needs to receive data from somewhere, it is the responsibility of that task to make sure that it invokes a result handler to put that data in a permanent place. Now, we do have sort of what you might call a greedy mode, where if you're very, very concerned that the downstream task might not even have the opportunity to cache the data, we can in fact fall back on what I just said is not great practice, but it can be appropriate where we literally write every single piece of data into storage and we never have to worry about losing it. But if all else fails, we pass data through storage, and we do it in a semi-intelligent way that helps us be efficient. However, because of technologies like Dask, which again, we love Dask, Dask ships with what I consider to be the best task scheduler. I should clarify, it's a slightly different type of task in Dask's world than the one that we're talking about in Prefect. Let's call Task the best way to run a distributed computation in Python, in my opinion. And it has this millisecond latency scheduler that can ship tasks wherever they need to go. But it also has a great serialization protocol. So when we're running on Dask, we don't need to use a cloud storage at all, unless we are in this retry situation I described before. Dask itself will take care of serializing the data intelligently and making sure that it's available to the tasks that need it. And Dask will go so far as to actually schedule tasks in the same node if it's appropriate, to minimize the latency and network requirements of moving data around. And so by leveraging both sort of a clever approach to understanding when do we need to serialize data properly, but also by using technologies like Dask that have shown the way to doing this very effectively in a concurrent setting, we've solved this problem in a very clean and effective way.
And another thing that comes up, particularly when running tasks across multiple nodes, is the issue of requirements, whether it's data availability or a certain set of dependencies that need to be installed on a particular instance. And so I'm wondering how you approach the idea of task affinity, where you say, I see this task coming in that needs to be scheduled and executed, and then understanding that it needs to be executed on a specific instance or within a specific location or capability. And then also in the event where it's not necessarily possible to have the specific node as part of maybe a Dask cluster, and you need to run it as just a one-off task or something that's scheduled out of band, how you would then handle capturing the status of the previous execution for being able to surface it within Prefect itself, and also for being able to maintain data lineage and provenance for tracking within the broader Prefect installation.
Yeah, excellent question. So for the moment, what we've discovered is that the majority of the use cases that we're dealing with today, within a given workflow, tasks tend to share affinity, or put a different way, whatever the most stringent requirements of any task are, it tends to be shared by others. So the easiest thing to do and the most common thing to do is build a single Docker container that contains all of the workflow logic. And now we can just reuse that Docker container anytime that we need to run any task in that workflow. And we know that the dependencies are there. We know that any special requirements are there. We sort of abstract this problem away. It's built in there. We do have a concept of task tags, where certain tasks can be, tagged, which is a way of demonstrating that they have a requirement or an affinity. This is something that we added very early in the system. And then, as I mentioned, we're like constantly showing things to people, seeing how they use them. This was something that just didn't get a lot of lift in the beginning. It was so it was so easy to just take the entire thing, chuck it in a Docker container, and just know it was going to run, that we just didn't see people using this feature. And so it's still there, but we haven't done very much of it. And to be honest with you, version 1 of our cloud platform is actually not going to like have a way to express this, because we are waiting for someone to really say to us, we absolutely need this right now as a higher priority than other workflow requirements. So in a very interesting way, when we just give people the power to describe the environment they need, and then execute it in whatever cluster they want. So you basically can describe whatever it is that you need. It solved, at least in the use cases that have been brought to us, the need to be hyper specific about each individual task. And in part, I think that's because Prefect encourages a slightly different workflow than what you might see in other workflow engines. And that's because each task in Prefect is designed to be small. We want a task to be a single piece of logic. And the smaller it is, the better it is, because that means that each task in Prefect can be checkpointed individually, in a sense. So whereas other workflow engines, especially ones that can't pass data around, they sort of necessitate these monolithic tasks that do just an enormous amount of things, because you can't pass the data you need to a downstream task, or you need to do a loop, or something that isn't just natively possible in the workflow manager. And so as a result, the idea that tasks would be very different from each other in terms of what environment they need isn't really one that comes up often in the Prefect ecosystem, because tasks are much more like a script, a Python script, than a discrete and different set of operations taking place in incredibly different environments.
And another challenge that can come up from the environmental context is the idea of needing to cross network boundaries, where you need to potentially distribute the task to maybe be co-located within a network environment that has access to the data. So maybe it's a Hadoop cluster with an HDFS file system that you need to be able to retrieve data from or store results into, but then it needs to be able to communicate with the application database that's running in a different network environment. And so I'm curious how you approach some challenges that exist along those boundaries.
Yeah, so here again, we are exposing the environment class, if you will, to our users, but primarily it's at the flow level. And what we found is that by appropriately pulling secrets and effectively running subtasks wherever they need to be, we've solved this problem to a large degree. One of the things we're working on now and trying to identify the best API for it is allowing per task environments, which would allow completely isolated deploys of a task, like not even bridging a network boundary, bridging an everything boundary into a completely isolated environment. We're actually soliciting feedback right now in our repo. If anyone out there who's listening has a strong opinion about what is the best way to express that, our default view is it's just to use our existing environment classes and allow people to override them on a per task basis. But obviously the devil's in the details, and we want to make sure we do this in a good way. But broadly speaking, when it comes to how do we run something in one place and another, it's just a matter of designing the workflow in a way so that the workflow itself runs itself in these two locations.
And so we've touched on a few of the different capabilities and features of Prefect, but I'm wondering what are some of the others that we didn't touch on yet, and particularly any that are often either overlooked or misunderstood by your users that you think would be valuable and that they should potentially exercise more often than they otherwise do?
One of the things that comes to mind, I mentioned earlier, we introduced this mapping operator. So when people discover our map, they're usually very excited, but we're not sure if we're doing a good job of educating people to its existence. So by way of history, one of the most common early requests or early use cases that we saw when we were designing Prefect was the ability to dynamically generate workflows. In other words, using information that was only known at runtime, we want to adjust the workflow. Now, I used to hack around Airflow to do this. Airflow has this, it's a feature or bug, depending how you look at it, where it reparses the DAG every time it runs a task, which means if you put workflow logic in the DAG definition, you can trick Airflow into running it for you. And so I would use that, for example, to get Airflow to create new tasks for new files that needed to be processed that I could discover at runtime, basically. But we don't like that because we don't like workflow logic to be running outside of the workflow governance system. That's bad in our eyes. So we discovered that rather than implementing a fully dynamic workflow, like you can put any task you want in any order you want and just generate a workflow on the fly, we actually found that almost every single use case that was brought to us was essentially an instance of mapping over a runtime known list. So that could be get a list of URLs that you need to go visit, or that could be get a list of user IDs that you need to process, or take things off a queue and work with them. And so what we ended up designing, and it really has solved this problem in a really elegant way, is any Prefect task, if instead of calling it, you just say .map, will automatically turn itself into a set of parallel pipelines, which then can be further mapped by downstream tasks. And you can basically extend these pipelines as far as you want and then reduce them at any time and work with their combined output. And so we internally, we love this feature. We do think, we talk about the Slack bot that we run on Prefect. And in all honesty, one of the reasons we talk about the Slack bot a lot is because it's the sort of thing that no one would ever dream of running in a traditional workflow system, but it runs great in Prefect, so it's fun to talk about. So our Slack bot runs stand-up every morning, and in order to do that, it has to send messages to everyone on our team. Well, we don't want to sit there and hard code every single person in our team into the workflow. It's a disaster. So instead, we use a map operator over a database that we keep anyway that has all of our Slack usernames in it. So we write one task to send a reminder, and then we map that task over the usernames, and now everybody gets a reminder every morning if they haven't sent their update yet. So this map operator is something that we love. We're really excited about. When people find it, they tend to love it too. But we need to do a better job about telling people about it. And then there's something else which we actually haven't talked much about because it's going to be tied much more to our cloud platform that's going to be coming out later this year, which is versioning. So versioning is one of those things, I can't remember now if I referenced it or not, but it was one of those really common requests where, I have a model or I have a workflow and I need to change it. And traditionally what you would do is you'd sort of blow away the old one, upload the new one, maybe you change its name to say version 5, and you would hope that you didn't make a mistake. And so we hate that, obviously, and coming from a data science mindset, I also don't want to get rid of my old versions. They have the metadata, the history is incredibly valuable. And so we have what we hope is a very simple, very generalizable versioning concept that we think will let people map whatever their preferred versioning logic is on top of it. And what I mean by that is some people think of versioning as a promotion of the new workflow, and you archive and just keep the old workflow for reference. Some people think of versioning as a way to do A/B testing, and you run two versions of something that are very similar, but you want them actually both active. And as we started researching this, we came up with a handful of different, what does versioning mean to somebody? And so again, we did the same exercise we do with pretty much every other use case. We stepped back, we abstracted the commonality, we exposed that in an API. And so I'm very hopeful that becomes a useful feature once we have this platform out.
And some of the other challenges and requirements that come up often in the context of workflow execution or ETL tasks are the issues of being able to do local development and execution for validating that the code that you're writing is doing what you want it to. And then also the idea of testability and being able to do validation both ahead of time and at runtime to ensure that your tasks are doing what you actually want them to do, or that your source data isn't introducing anomalies or defects. And so I'm curious how Prefect handles that, what the interfaces for those capabilities look like.
Yeah, so this is going to sound like a cop-out answer, but it's a very important one. When I said we literally treat anything, as a Python function, that's what we're asking for. We mean that. So when you build a task in Prefect, it is a Python function. It behaves like a Python function. You can call it like a Python function. And most importantly, you can test it like a Python function. So if you go look at Prefect's unit tests, and I'm extremely proud of how many thousands of unit tests there are, you will see complex workflows being generated in the unit tests and then being tested right there. And we can instrument those tests. We don't have to run the whole workflow end to end. We can supply, we can basically override the output of certain tasks. So I can test that the 7th task, if I force it to return a failed state, I can test that the 8th task is going to respond appropriately. And so we have an entire test utility that ships with the Prefect engine. So we basically took all of the little things that we were doing to make our lives easier as we wrote these unit tests, and we turned them into utilities that anybody can use. Even things like temporarily overriding configuration or temporarily setting environment variables. We have context managers to do that. So we took this same, sorry if I sound like a broken record, but we just took the same idea of Python is a friendly known API. How do we expose that sort of same level of just accessibility throughout everything in our platform? And tests are just like that. So testing a Prefect workflow is an awful lot like testing Python. If you want to use, a set a breakpoint in the middle of a task and then jump into an interactive session when that breakpoint is hit, go right ahead. It will work. All of your tools are available to you because it's just Python at the end of the day. Now, if you want to do testing in a distributed setting where maybe you can't just set that breakpoint, you've gotten past, you're comfortable locally, you want to distribute it, we're working on a variety of tools for debugging. And so here, obviously starting with logs, you want to make sure that you log so you know where you are. We want to make sure that you have a way to recreate that task state at any time. And so as people are getting more and more into deploying these things and wanting to make sure that contracts are kept and data quality checks, we'll be rolling out more and more of our tooling for ensuring that as well.
Yeah, as you mentioned, the response to a few of my questions has been along the same lines, but I think that that's just a signal of good design and a good amount of foresight in terms of how you approach the problem space. Because if you don't have to have special cases for every different type of uh, instance or context, that means that the tool itself is built in a way that you're able to do what you need to do without having the limitations placed on you, like you were mentioning.
Yeah, and look, I appreciate you saying that. I would invite anyone out there, like, you don't have to take our word for it. We're talking about an open source package. You can go see our docs. You can go play with it. We did work extremely hard to make it feel like Python, because nothing turns users off faster than having to learn a language that is almost but not quite exactly like Python in order to build a workflow. And honestly, Tobias, there's no one here on our team that's going to take credit for necessarily having the foresight to know, like, this is a good way of doing it. This is just because um, uh, we have just made such a strong effort and such a real attempt at outreach to make sure that nothing we do is in a vacuum. Everything is shown to our partners. We had more than 100 people who were partners before we open sourced the package, using it, doing formal research with us, giving us feedback. Some of them would call us every day. Some of them, honestly, we heard from once and we didn't really hear from them again. But we tried so hard to make sure we had this broad group of partners, honest, legitimately partners, so that we didn't have to guess and be right. We could fail quickly when we were wrong, and I think that we're all very proud of the API that we've developed, and we're happy when we see data science students picking it up and using it for projects, and we're happy when we see it deployed into massive architectures, because for the same product to do both ends of that spectrum is something we're very proud of.
And so, as you mentioned, you have a cloud platform that you're working on getting deployed, and you also have the open source core capability of the Prefect engine. And so, I'm wondering if you can outline the differences in terms of feature sets and capabilities between those two offerings, and what the limitations are on the open source repository as compared to the cloud platform.
Yeah, so we don't ever want to think of it in terms of limitations, to be honest with you. So Prefect didn't start life as a company. It started life as something I was building, honestly, for me. And so in many regards, it takes all the things that I hate about working with most open source tools, and we just said we're just not going to do that. So our cloud platform is not, a gated version of our open source package. It's a completely separate product, and it's very important to explain, why do we have this distinction? No one should ever use our open source workflow engine and worry that, oh, we have to pay to get, the retry logic or something like that. I can't even think of a good example. The way we think of it is Prefect Core, which is what we call our open source. That is a workflow engine. That is where everything that you need to design the workflow, to test the workflow, to execute the workflow, to package the workflow, to deploy the workflow, to log the workflow, to do the result handling, every single thing you could possibly need is in that open source package. And it is an engine. It is a very powerful engine. Our cloud platform that's coming serves a very different need. So once you have a workflow and it's been deployed, it's in production, and we have plenty of people who have put Prefect Core, the open source package, into production, there's a different stakeholder, well, it could be the same person, but often it's a different stakeholder, who becomes extremely interested in what we would call state and interaction, which is to say the metadata that these workflows are throwing off. So that's things like making sure the run history went, doing scheduling in a much more sort of rich and robust way than what we're able to do in the open source, which is sort of bound to a single processor and not going to be asynchronous. And that is where we see the value of our cloud platform. So our cloud platform is where we ship a database, a GraphQL API for interacting with that database, and the database, of course, is for storing state history. Our UI is in the cloud platform. Really, the way we think of it is if Prefect Core is the engine, then Prefect Cloud is the car. And the car is completely worthless without the engine. Our cloud platform literally can do nothing without the capabilities that are imbued to it by Prefect Core. However, it brings to Prefect Core a variety of things that one could very easily build on top of Prefect Core if one were so inclined. But we don't really see a reason to do that. We have some opinions about the best way to handle the state and do things like make sure tasks only ever run once, certain guarantees that we're able to make, certain ways of tracking logs and exposing them. And so that's where we bring our cloud platform to bear. And so we're pretty excited about being able to offer it. It's important to us, as I mentioned, like open source is a value of our company, and so it's very important to us. There will always be a completely free tier of Prefect Cloud, which will not have features stolen from it that one would have to pay to unlock. We think it's just fundamentally wrong to hold out an open source project and then tell people that, oh yeah, we have this other nice thing that it's not quite it, but it's different, and sorry, you're not able to use it. We'll never say that.
And going into the initial implementation and design of Prefect as just a personal project, and then as it grew in scope and ambition to be a company built around this idea, I'm wondering what were some of the assumptions that you had initially and how they have been challenged or updated as you continued to dig deeper into the problem space and start receiving feedback from users about other ways that they are leveraging the capabilities of Prefect and other adjacent tools.
Yeah, so as I mentioned, we always designed Prefect with users in mind, so that when we were wrong about stuff, we could fail relatively quickly. Like, we could learn that early. So there have certainly been many times when that's happened, but fortunately, as a matter of structure, we haven't allowed them to progress too far. Many of them I won't bore your audience with, because they deal with certain like details of the API. But one thing that comes to mind is actually we made a mistake that I now see echoed throughout the sort of data engineering space, which is that we assumed that we would be working with big data or machine learning or complex use cases, and we prepared an enormous amount of outreach and messaging around such use cases. But what emerged when we actually started bringing this to people is something that we sort of jokingly call the apology. And it's this moment in many of our customer interactions where someone will apologize to us. And it's a little bit odd, to be honest, because the apology always has the following form. They'll say, I'm really sorry that the problem we're actually having isn't about big data. It's about this CSV file we have that only has, 1,000 lines. We get it every morning, but it's in, I don't know, some odd format, or the first column is blank, and so we can't import it properly into our software. And so there's this apology moment where it turns out the problem is not big, and it's not impactful, except to this person who has to go deal with it all the time. And so we learned to shift ourselves a little bit, and we realized we are tackling small problems. We're tackling annoying problems. We're tackling the things where the most common way people describe it to us is, this should be easy, but it's not. Whereas the mistake was to go out and assume we were going to tackle the things that we all agree are hard. So that's been a really good, interesting lesson for us to learn. And now it's one of the ways that we can very quickly judge, is Prefect going to fit in well with this organization? Because when that apology moment happens, and I'm calling it the apology facetiously, of course, but when that moment happens, we know that this person has something that is meaningful to them. It's a problem that many other tools don't deem important enough to solve. But as I mentioned with our Slackbot example earlier, Prefect's a great solution there because it's so easy, it's so lightweight, and we love, frankly, we just love helping people with something they hate to do. So that's been a really important lesson, and that's been one that scales, because once that person gets that CSV file working the way they need to, now they've freed up their time to go work on the thing that they actually want to be doing, which is some giant analytic data set. And now Prefect is already demonstrating its value to them in a concrete way. Now it's very easy to understand how it will demonstrate its value at scale as well.
Continuing on that idea of different edge cases or interesting problems that people are tackling with it, I'm wondering, what are some of the ways that you've seen Prefect used that were particularly interesting or innovative or unexpected?
Oh, we've seen some very cool things. I mean, some of the most interesting ones, honestly, come from internally. As you can imagine, anyone who joins Prefect, no matter whether they can code or not, they immediately begin writing flows as a way of just getting comfortable with the language of our company, if you will. And so we have someone here who uses Prefect to remind her that she needs to do laundry. And so I just always love that, because it is, again, like the Slackbot, it's just so completely different than anything you would think from a data engineering tool set. But when you step back, it makes perfect sense, right? We have something we need to do. that's got to interact with an API. In this case, it's a Slack message on a regular schedule, and it has strict dependencies. And we want to make sure that it, retries itself. We want to guarantee that it succeeds. So apart from the fact that you might, instead of, in this case, reading a value out of a Firestore database and telling someone it's time to do laundry, you might, instrument that Firestore database itself. It all comes back to this idea of Prefect is about the arrows, not the boxes. And so we've seen just a huge variety of things. I'm trying to think internally. We have designed flows that tell you if your plane is laid. We've got flows that calculate the value of a portfolio, and then in bigger terms, we've got a flow that downloads terabytes of data from NASA every night. In fact, that's a good example of where the apology matters. It turns out that the bottleneck there had nothing to do with the amount of data, the processing of the data, the storage of the data. The bottleneck there was actually just that sometimes the connection to NASA failed and it needed a retry. And it's sort of extraordinary. When we fixed the retry, which is all of 2 lines of code, all of a sudden we were able to enable this massive workflow. It was just so exciting to see. So the spectrum of things we've seen Prefect deployed into is wider than you can imagine, and I'm confident it's being used for things that we haven't even contemplated here.
Conversely, Prefect is this flexible tool that you can do all kinds of different things with, but when is it the wrong choice?
Well, so it's a very important question. Prefect is the wrong choice when, for example, Prefect is the wrong choice when TensorFlow is the right choice. So Prefect is not a tool for building, for example, backprop, implementing backprop for training a machine learning model. Could you do it in Prefect? Sure. Prefect is Python. You could go right ahead. But we would never recommend that you do that because you'd be forgoing amazing specialized tools for doing that purpose. What we'd love for Prefect to be is to be the glue around those specialized tools. And that's why it's so important that Prefect has this very flexible, very agnostic API. So we're not out there trying to replace software. We're out there trying to play nicely with software. So when there's a tool, and TensorFlow came to mind first, where you are trying to do a very specific application-specific thing, use that tool. Wrap it in Prefect, but use that tool. And then, in fairness, try and give you answers that are more connected to a business purpose. We've had a surprising amount of interest from the high-frequency trading community. And in honesty, those are usually calls where we suggest other tools. So when we talk about speed and scale for Prefect, we're talking about being able to do things in a near real-time fashion, or in what we consider scale. But some of these firms that we talk to, that I interacted in a different life, interacted with in a different life, are doing things at an order of magnitude difference. And the guarantees that we make in Prefect are just not at the nanosecond level that they are looking for. I don't even think Python is the right language in that choice. So that's an example of a field where Prefect is probably just not the right tool for that job.
And speaking a bit more broadly, based on your experience of being somebody who works in the industry as a data engineer and a data scientist, and then now in your work with Prefect of interacting with all of the users and partners as you try to iron out the capabilities and direction of Prefect, I'm wondering what you have found to be some of the common anti-patterns or challenges that arise in data engineering projects, and some of the overall best practices and industry trends that you're most excited by.
So this talk I gave at PyData touched on this issue in a big way. It was all about basically how people hack around their workflow system. And this is an anti-pattern that we are very sensitive to because I spent an awful lot of time bug hunting in Airflow, and this was often the culprit. When systems, and for our purposes today, let's talk about workflow engines, but almost any bit of infrastructure could probably fall into this heading. When a system doesn't do exactly what you need, but it does most of what you need, you work around it. And as well as I do, code is code, right? We can make it do pretty much whatever we want if we really try hard enough. So the danger is that systems can only make guarantees about what they expect to be working with. So when you go around the system, you encounter what, when I oversaw risk management, I would call wrong way risk, right? You encounter an environment in which when things go wrong, you have willfully stepped away from the governance and the guarantees of the systems that you put in place, which means that when they go wrong, you don't even find out that they went wrong. The system has no mechanism, has no vocabulary to protect you anymore. And so what could have been an error can turn into a catastrophe very quickly because you went around the system that was supposed to implement those safeguards. And so this is an anti-pattern that we see, certainly not generally, but commonly enough that it influences our design on Prefect. And so earlier we talked about the difference between Prefect Core and Prefect Cloud. And increasingly, I've come to view Prefect Cloud as a risk management tool where we hope people never look at it. I mean that in a very honest way. We have a design goal that 90% of the time someone should log into it, see a bunch of green lights, and leave. That would be a successful outcome for us because we're very sensitive to this idea that if people need to go around the system, we, or whatever system it is, won't be able to accurately report and reflect back to them the situation that is most meaningful to them at that moment, which is inevitably some sort of error, some sort of failure. And so that is an anti-pattern that we see, which we are really, really, really doing our best to never give someone a reason to go outside our system, or at least be very upfront about how we recommend approaching certain problems. So the flip side of that question, I think you asked me, is what trends am I excited to see? And there's a few. I really love seeing data engineering sort of blossoming into an industry in its own right, rather than being sort of a necessary outcome of the progress that's being made in the data science world. Like that's wonderful. That's awesome. The hiring statistics for data engineers, we obviously look at these types of things, are outpacing those for data scientists for about the last year for the first time. And this kind of growth, this kind of interest, these sort of like specialization tracks is wonderful to see, because at the end of the day, I can build the greatest model in the world, the greatest analytic in the world. It doesn't do me any good unless I know that it's going to be put into production. And the best way to make sure it gets put into production is to have wonderful, competent, trained people who love data engineering. And data engineering is like this nebulous thing. You talk to 10 people, well, what is data engineering? So to me, data engineering has come to mean, or rather, let's put it this way: an expert in data engineering is someone who understands the access patterns of data. So I don't look for a data engineer to be an expert in Postgres or MongoDB or any single one database, but I expect them to understand the access patterns and the compromises and the trade-offs that would be made no matter which underlying technology is used, and similarly for any other technology in the data engineering stack. So one thing that I love seeing is data engineering just blossoming into this institution in and of itself, which speaks to just broadly the growth and the importance of data in the modern business world. It's just awesome to see. Another thing I love seeing are cloud-first technologies, things that just would not have been possible 5 or certainly 10 years ago. My favorite example is that I can use BigQuery for anything, for any project I have. BigQuery is this technology that when I implemented it many years ago in an organization I worked for, delivered an order of magnitude performance improvement while reducing costs by a similar proportion. And that was just this incredible moment. I mean, I read the docs, I didn't believe it was possible. So I love seeing technologies like that come to bear. We've loved working with Google because they make a lot of these things available. And so that's something that's very exciting to me.
And looking forward, what do you have planned for the future of the Prefect project and company?
Oh, so much. We are very focused right now on getting our cloud platform out to our early partners, which is happening, more or less as we speak. Maybe by the time this is released, it will have actually started. That is our number one focus right now. We're working with some really wonderful companies in the same vein as we did with our open source project to make sure that this is incredibly successful product and project. And then more tangibly, we are working on some very interesting things in our open source as well. We're working on something we call a listener flow, which is going to respond to a customer request for more event-driven workflows. So the idea there is basically in response to some asynchronous event, a queue, whatever it is, we're able to launch flows in the same process so that they can share memory and all these other benefits. And many of these sort of planned features, we write them all up. We write up all of our design decisions. They're in our docs. We open source them and we discuss them. So even when something's in the idea phase, you can usually go off and it's a lot more information than you'd see on just a roadmap. It's a proposal. It's a full proposal, often with code, of how we think we should do this, and we invite people to comment and let us know what they think of that design.
And are there any other aspects of the Prefect project and business and the overall state of the industry as far as workflow engines and data integration that we didn't discuss yet that you'd like to cover before we close out the show?
I feel like your listeners might murder me if I just keep talking about filling the gap and putting Prefect in as glue. So I will spare everyone I'm very, very grateful for the opportunity to talk about what we're building. My whole team is very excited to finally have something that we can show in public and talk about.
All right. For anybody who does want to follow up with you or keep track of the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Having just said what I just said, it would be embarrassing to walk it back. But Prefect was a project because it filled a need of mine. Prefect is a company because I literally couldn't find something that did what we're doing. And it was the single biggest problem in my world. But I won't just talk about Prefect for a moment. In a more general sense, I think that there's a trend in the data engineering software space where companies are building a thing that solves their problem and then they're releasing it to the world. And sometimes, but not always, that technology can be readopted for individual use cases or whatever someone needs to solve. But we don't see a lot of companies that are building things that are truly generalizable. And that makes perfect sense, right? Very few companies, almost no companies, are actually incentivized to build something that solves anyone's problems but their own. And something that we have learned as a business is that there's a structural belief that if you have a problem and there isn't a third-party package solving it, it must be something that's unique to your business, and as such, it must be correlated to something special that you're doing as a business. In a very interesting way, it's part of your competitive differentiation. So one gap that we see is that this push towards large companies, which again may share almost nothing in common with the use cases of the majority of companies, pushing their technology out and saying, this is the way to do this, has led to what I would consider suboptimal outcomes. And so open source is one way to combat that, although open source is not immune to what I'm describing. Many popular open source projects themselves started within large companies. And so, I don't have a magic bullet that would solve this, but to the extent that we are cognizant of a fear I mentioned earlier, that folks can work around a system to get it to do what they want, and in doing so abandon the guarantees that system is able to make. That's a fear I have as the data engineering world expands in ways that I otherwise think are really incredible and wonderful.
All right. Well, thank you very much for taking the time today to share your insight on the state of the industry for workflow tools and the work that you're doing on Prefect. It's definitely an interesting platform and one that I plan to start experimenting with on my own. So thank you for all of your effort and energy on that front, and I hope you enjoy the rest of your day.
Thank you, Tobias. Thank you for having me on. Thank you for inviting me to speak with you today, and I really appreciate the opportunity. Hope you have a wonderful day as well.